Hey Spartans, Miss Hester here, and here's my little pony Applejack eating the apples. We're at the rodeo arena, so I'm not here today. Move over, Applejack. And you've got these notes to take that you picked up outside. Okay, so what we're going to talk about today are proportions. And a proportion, P-R-O-P-O-R-T-I-O-N, is an equation formed by two equivalent ratios. So like the EFT chart, 1/2 is equal to 5/10, and so on and so on and so on. Okay, so let's fill in these notes. If you recall, when we set up our proportion last week, I think it was, we had apples and we had pies. And remember, the placement of labels and numbers do matter. Also, building a table can also be helpful too. This is my best friend table. Hi, best friend. Ta-da. So if you ever hear me say, build your best friend table, that's what I'm talking about. So it's basically like an EFT chart with labels. Now, when you're making two proportions and making sure they are equivalent, you have to keep them organized. Example, if we were to have apples on the top, well, this number has to be apples and this number has to be apples. And if pies are on the bottom, you got to have the number of pies with another number of pies. You can't get them mixed up. Or you could switch it around and put the pies on top and the apples on bottom. Either way, that's fine. This is good. That is a yeah. Good, good. But what if we want to turn this table vertically? And I want to have the apples on the left side and pies on the right side. That's still okay. Or if I switch them around, I want to put pies on the left side and apples on the right side. That's still okay. I say, yeah, go ahead. Now, non-examples is if, like, I say, well, we're going to have apples on the left and pies on the right, and then I switch it. No, pies on the left, apples on the right. You can't get your material crisscrossed, and you can't get your numbers crisscrossed, because then everything would be out of sorts. So this is a very much a no. In fact, it's poo, which comes out this end of the horse. So, keeping it organized, yeah. Crisscrossing it, no, poo. All right, out of the way, Applejack. Okay, coming down here, try this. Setting up a proportion. If 2 lemons are needed to make 5 glasses of lemonade, circle all the proportions that could be used to find the number of lemons. We'll use L for lemons to make 45 glasses of lemonade. So we want to find the ones that could be used. We are looking for the yeah. So what I want to do is label all of the 5s. What are the 5s? The 5s are glasses. So put a G next to all the 5s. Glasses, your glasses, and your glasses. And all the 2s are lemons. So put an L next to all the 2s. Okay, once you get your labels done, what I'm looking for next is to see if I have any L's that are crisscrossed. These are straight up and down, and the 45 is also glasses, so I could put G for all the 45s. Sorry, I forgot to do that. Label the 45s with G's because those are glasses. All right, now I'm looking for G's and L's crisscrossed. L's on the right, G's on the left, G's are on top, L's are on bottom, G's on the bottom, L's on top, L's on the left, G's on the right, L's on the top, G's on the... Okay, that didn't help me. Everything is labeled with glasses and lemons. None are crisscrossed. Now, the next step is to know that these 2 lemons have to go with the 5 glasses of lemonade. 2 lemons, 5 glasses of lemonade. See how they're crisscrossed? That's bad. Poo-poo. All right, 2 lemons, 5 glasses of lemonade. That one's good. Yeah. 2 lemons, 5 glasses of lemonade. That one's yeah. 2 lemons, 5 glasses of lemonade. All right, we're doing good. All right, last one. Oh no, 2 lemons, 5 glasses of lemonade. Purr. So the ones that are good are these 3 right here. Yeah. Okay, to the back. Sorry, organize. Okay, let me zoom in a little bit. Whoa. Okay, we're going to do 4 different ways of solving problems. One is finding a multiplier using the multiplicative comparison. It's not as hard as it sounds. Here we go. The recipe that Sylvia, or if you want to change that name, go ahead, is using says 10 apples are needed for 2 pies. How many pies can she make with 55 apples? Well, this is kind of from our problem last week. So let's build that best friend table. Okay, the 2 things we're comparing are apples and pies. So I'm going to put an A and a P. I know that 10 apples make 2 pies. So the question is, how many pies, put a little question mark there, does she need for 55 apples? Now, can 10 jump to 55? 10, 20, 30, 40, 50? No. So try to look vertically. Can 10 jump to 2? Yes. How does 10 get to 2? Divide by 5. What you do to that side, do to the other side. Divide 55 by 5, and our answer is 11 pies. Put in a little bubble. There we go. Ta-da! Easy peasy. Okay, number 2. The recipe that Sylvia, or some other name you want to use, is using says 10 apples are needed for 2 pies. All right, we already have that. Let me go ahead and set up my best friend table. Apples, pies, 10 apples, 2 pies. Okay, how many apples are needed? So we're looking for the apples for 6 pies. Now I can jump from 2 to 10 times 5 and do the same to the 6, or I can jump sideways. Check this out. How does 2 get to 6? Times 3, and what you do to the bottom, do the same thing to the top. 10 times 3, that equals 30 apples. Isn't that right, Applejack? Yes! All right, so put a little bubble around it. That's our answer. Sorry, kiddo, out of the way. All right, so we found one using a multiplier, using multiplicative comparison, the other factor of change, all fancy words for saying check vertically. Can you use those numbers to help you find the missing value? Check horizontally. Can you use those numbers to help find the missing value? And always remember, it's multiplicative. Find a multiplier. All right, next one down. Simplify the ratio, then find the multiplier. Okay, yesterday Melissa rode her bike for 4 miles in 14 minutes. All right, I already see what I'm comparing. Let me make my table. I'm going to put an M for miles, and I'm going to put MIN for minutes. I know 4 miles is 14 minutes. Okay. Her goal today is to ride her bike for 70 minutes. If she travels at the same rate, how many miles will she travel in 70 minutes? All right, so we're looking for the miles in 70 minutes. Now, can 4 and 14, can 4 jump to 14 through multiplying, or 14 to 4 through dividing? No. Do you know what 14 times something is 70? I don't know. So what they want us to do is simplify here. That just means reduce. Write that down, please. Reduce. So we're going to take 4 and 14 and we're going to make them into some smaller numbers, and maybe those numbers can help us out. Divide it by 2. I get 2. 14 divided by 2, I get 7. Now 7 is way easier to jump to 70 times 10, and 2 times 10, that's going to be 20 miles. Boom, 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 boom. All right, so we've looked for the relationship horizontally, didn't have one, vertically, didn't have one. We reduced it down to smaller numbers and then found out that was much easier to build up to where we needed to go. The next one says to find a unit rate. The unit rate is the price of 1, or the amount for 1 unit. At the Cy-Fair candy shop, 2 pounds of chocolate cost $1.52. Ooh, I'll take some. At this rate, how much would 5 pounds of chocolate cost in dollars and cents? All right, let me set up my best friend table. 2 pounds, I'll put P for pounds. 2 cost $1.52. I'll just put a dollar sign. $1.52. And we got to go from 2 pounds to 5 pounds. But I know 2 can't jump to 5. And I don't know what 2 to 152 is, but I bet I could find out. Let me find out what 1 pound is. Divide this in half, I get 1. So take $1.52. Divide that by 2. Let's see, 2 can't fit into 1. 2 fits into 15 7 times. Subtract, I get 1 left, bring down the 2. 2 fits into 12 6 times. So 1 pound cost 76 cents. Okay, so then how do I get to 5 pounds? Well, to get from 1 to 5, it's just a times 5 jump. So what I do to the top, I'm going to do the same thing to the bottom. So I'm going to take 0.76 times 5. Here we go. 6 times 5 is 30. Carry the 3. 5 times 7 is 35, plus 3 more, 38. Okay, I ignored the decimal. There were 2 places. I got to put them back. 2 places. So 5 pounds will cost us $3.80. Boom, 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 boom. All right, so what we did there, they gave us a price for 2 pounds. We found the price for 1 pound. And then once you find the price for 1, you can multiply it up to find the price of any of them. Okay, example number 5. What if the multiplier isn't easily found? Okay, we're going to do this side first. We're going to use cross multiply and divide. This is from the good old days when Miss Hester was in 6th grade. Well, we probably learned this in 8th grade. It was easier times. All right, let's see what it says. Giovanni is baking cookies using his grandmother's recipe. For 2 batches of cookies, the recipe calls for 5 cups of flour. How many cups of flour will Giovanni make in 8 batches? All right, 2 things we're comparing are batches and cups of flour. So I'll use a B for batch and a C for cup. I know 2 batches takes 5 cups, and then 8 batches would be how many cups? Now, I see the multiplier to get from 2 to 8. That is easy. Let me come over here and build my best friend table again. Batches to cups. 2 batches needs 5 cups of flour. How many cups of flour will 8 batches need? So the multiplier between is a times 4. So 5 times 4, well, that gives us 20. And that's our answer there. Will the cross multiply and then divide work? So what you do is you look for 2 numbers that are diagonally across, like this 8 and this 5. And then what is 8 times 5? Well, that equals 40. So cross multiply, you get 40, and then you divide by what's left. What's left is this 2. So 40 divided by 2, that equals 20. Did I get the same answer? I did. So if you ever find yourself stuck and you can't find a multiplier vertically or horizontally, and unit rate has got you confused and you're not able to reduce, you're welcome to do cross multiply and divide. But I mean, if you can avoid it, try avoiding it. You would have to do 70 times 4 and then divide by 14. That's a lot. Over here, you would have to do $1.52 times 5 and then divide it by 2. So sometimes it's easier, but actually the numbers you get in 6th grade should be nice and friendly like these. Okay, let's go to your next worksheet called Purposeful Proportions. Okay. Now if you feel like you want to try this on your own, just ask for the video to be paused and then we can come back to it. But how about we start like the first one together at least, and then you pause. For each scenario, identify the quantities being compared. Then write and label a proportion, 2 equivalent ratios, and solve the unknown amount. So basically build a best friend table and label it. Here we go. If 2 lemons are needed to make 5 glasses of lemonade. I have seen this before, wasn't it? Right here. Okay. 2 lemons are needed to make 5 glasses of lemonade. Then how many lemons L are needed to make 45 glasses of lemonade? All right, let's build our best friend table. 2 things we're comparing, lemons and glasses. I know I need 2 lemons for 5 glasses of lemonade. 2, 4, 5. Okay, and then we need to know how many lemons, so I'm going to put a little question mark up here, are needed for 45 glasses of lemonade. Okay, so to get from the 5 glasses to the 45, that's just a times 9. 9 times the glasses, I need 9 times the lemons. 2 times 9 is 18. It means we need 18 lemons for our 45 glasses of lemonade. Now I'm getting thirsty. All right, the next one. Pause if you want, and then come back, or we could just keep going. Decide? Decided. A local clothing store sells 4 pairs of jeans for $36. All right, 2 things we're comparing. Pairs of jeans and money. All right, so let me go ahead and build my table. I'll put a J for jeans and a $sign for money. I know 4 pairs cost $36. Okay, what is the cost? That's what I'm looking for 9 pairs of jeans. Now, can 4 jump to 9? No, not very easily. But can 4 jump to 36? Yes. 4 times 9 is 36, so what's 9 times 9? $81. And that's the cost of a pair of jeans. Oops, let me write what we did. We did a times 9. Sorry, details. All right, so either you look for the relationship horizontally or vertically. All right, next one, number 3. It says simplify the ratio. You know what simplify means? Reduce. All right, so let's build our table because I know it's coming. A pitcher is 9 inches wide and 12 inches long. Okay, let me go ahead and write that down. 9 and 12. So 9 is the width. 12 is the length. 9 and 12. If the pitcher's reduced, we know what that means, shrinks in size so that the length is now 8 inches. All right, so you're going to go to 8. And the pitcher keeps the same length to width ratio. What will the W? The width of the reduced pitcher. Oh my God. Can 12 jump to 8 or 8 times something be 12? Nope, those don't work nicely. Can 9 and 12 be multiplied back and forth? No. So then we have to do what they said. Simplify it, reduce. So what you do is you take your numbers that they gave you, 9 and 12, and you try to make them smaller. 9 divided by 3 is 3. So what's 12 divided by 3? That would be 4. Aha! Now, can 4 easily jump to 8 so we can figure out what the width is going to be? Yes, 4 times 2 is 8. So then you do the same thing to the 3. That means it's going to be 3 times 2, which is 6 inches, and this is the width. So I'm going to say 6 inches wide on that picture. Ta-da! Number 4. At Cypress Middle School, 4 out of every 6 students have brown eyes. If Mr. Newman has 150 students, what is B, the number of students who would be expected to have brown eyes? Well, let's organize our stuff here. Okay, I know 4 out of every 6 have brown eyes, so 4 out of 6. Now the 4 have the brown eyes, and the 6 is like his total students. 4 out of every 6 total students. Now if he has 150 students, can I jump from 6 to 150? I'm not sure. I don't think so. Maybe we can. I don't see the relationship. Can 6 and 4 be multiplied back and forth? No. All right, so what I'm going to do is reduce the 4 and the 6. I'm going to go ahead and cut it in half. That gives me 2, and that gives me 3. Aha, look at this. Can 3 go to 15? Yes. 3 times 5 is 15, and then add the 0. So 3 times 50 is 150. So 2 times 50 is what? 100 brown eyes. I-E-Y-E-Y-E. Brown-eyed students. Whew. What color are your eyes, Applejack? Ooh, they're green. Never seen a green-eyed horse before. Okay, number 5. Find the unit rate. Remember, the unit rate is the amount for 1. At a farmer's market, 1/4 of a pound of pecans costs $2.75. If Kyle purchases 3 pounds of pecans, how much will he pay? All right, let me make my little table. I'm comparing pounds. I'll put a P and put 1/4. And we got the price, so I'll put a little dollar sign and I'll put 2.75. Okay, so what's happening here? I know 1/4 of a pound is 2.75 and he wants to go to 3 pounds. But they suggested I use their unit rate, which is a good idea. If I can find the price for 1 pound, can't I jump to 3? Yeah. So I got to get from 1/4 to 1. So look at it this way. Here's a circle. I cut it into quarters. How many quarters does it take to get to be 1 whole? It takes 4. So if each little quarter here, that's 275 plus 275 plus 275 plus 275, that's 4 quarters to make 1 whole. So I need 4 275s. Oh, let me put it in over here. I got a little bit of room. 2.75 times 4. Here I go. 5 times 4 is 20. Carry the 2. 7 times 4 is 28, 29, 30. Carry the 3. 2 times 4 is 8, plus 3 more, 9, 10, 11. All right, I ignored some decimals, 2 places, back it up 2 places. 1 pound cost $11. So what would 3 pounds cost? $33. That's our answer there. Don't get confused with the work I had to fit inside that little tiny box. All right, next one, number 6. Charlie is making copies of flyers to advertise his new club at school. The cost for 25 copies, all right, we got copies, is $3.75. Set up my table, C for copies, dollar sign for money. 25 copies cost $3.75. All right. Question. What is the cost? What is C, the total cost Charlie will pay for 40 copies? Wow, I sure wish 25 could jump to 40, but it can't. But if I can find the price of 1 copy, then I can build that 1 copy up to 40 copies easily, and then I'll know what the price is for 40 copies. Wow, that was like an earthquake. It knocked Applejack over. Okay. All right, so I got to get from 25 to 1. That means I have to divide by 25. So I must take 375 divided by 25. I'm going to use this little line to help hold my dividing house. $3.75 divided by 25 copies. Don't be scared. Lift it, stick it, and start dividing. 5 cannot fit into 3, so nothing goes there. 5 fits into 37. 25 fits into 37 one time. 1 times 25 is 25. Subtract. I get 12. Now what? Let's bring down the 5. Now I have 125. How many 25s into 125? 25, 50, 75, 100, 125. That's going to take 5 25s, which does give me 125. So that means I'm done. That is 15 cents per copy. Now at 15 cents per copy, I need 40 copies. So I'm going to come up here. And I'm going to take my 40 copies times 15 cents and start multiplying. 5 times 0 is 0. 5 times 4 is 20. Scratch. Pakak. Lay an egg. 1 times 0 is 0. 1 times 4 is 4. Add those together. That gives me 600. Oh, but wait. There were 2 decimal places. 1, 2. Back it up. 1, 2. Final answer, $6 for 40 copies. Bum, ba, da, bum, bum, bum. To the back. Okay. Number 7. Oh, they want us to figure out which proportions are good or bad. So we might be looking for ya. We might be looking for whoop. Let's go see. Patricia drives 20 miles in 15 minutes. Okay, we got miles in minutes. Which proportion can be, so we're looking for a good one. We're looking for a ya. Can be used to determine X, the number of miles Patricia can drive in 1 hour. So they got it labeled for us real nice. We got 15 miles, 15 minutes, we got 20 miles. Wait, where did 60 come from? Oh, 1 hour. 60 minutes. Got it. All right. So we got minutes crisscrossed here. Are they supposed to be crisscrossed? No, don't pick that one. Okay, on B we have minutes. What just happened? Oh no, my screen. Ooh, I stood still too long and it shut down. 25 minutes is the cutoff. Okay, so minutes to minutes, miles to miles. That one looks okay. Minutes to minutes on top, miles to miles. That one looks okay. Miles, minutes, minutes, miles. Oh no, this one's got crisscross, so that one's out too. All right, so it's either B or it's C. Now what I know is 20 miles has to be with 15 minutes. That's the relationship, 20 miles and 15 minutes. So you see how this 20 miles and 15 minutes are lined up? That's a good thing. See how this 20 miles and 15 minutes are crisscrossed? That's poo-poo. So B is the good proportion. Ta-da! Number 8. At Nick's school, there is one teacher for every 18 students. So I know all the ones are teachers. So put a T next to all the ones. And 18 are the students. So put an S next to all the 18s. Okay, and we know that there are going to be 504 students at the school, so 504 are all students as well, pretty much. Which proportion can be? So again, we're looking for yeah. So if you see any S's or T's crisscrossed, let's get rid of those. All right, A, T's are on top, S on bottom. B, S and T got crisscrossed. You're out, B. T's on top, S is on bottom, T's on the left, S is on the right. Okay, the other three are good so far. Now what I know is that one teacher has to be lined up with 18 students. See how this is crisscrossed? This is saying one teacher gets 504 students. Yeah, that's not going to work for me. Okay, C. One teacher, 18 students. So these are lined up good. And then D, one teacher, 18 students got crisscrossed. They're giving me 504 again. No, you're out, D. C is the good yeah. Almost done. Number 9. A certain baseball player is currently hitting 2 home runs for every 25 at-bats. So I'm going to put, everywhere there's a 2, I'm going to put a H. You're a home run, you're a home run, you're a home run, you're a home run. So I got those all home runs. And the 25 is the at-bats. So it looks like they're calling them B. So B for all the 25s to be the at-bats. There we go. If he continues at this rate, which proportion could not? All right, we're looking for the poo-poo. Yes, you show your parents this paper. It's got poo-poo written on it. Don't blame me. Which one could not be used to find B? The number of at-bats it will take him to hit 10 home runs. So the 10s are the home runs. Home runs, 10 home runs, 10 home runs. Okay, so here the home runs and the bats are lined up side by side. Home runs, bats, those are good. Home runs on the left, bats on the right, those are good. Home runs are crisscross, bats are crisscross. This one's bad, which means that's the answer we were looking for. Last answer, or last question. Woohoo, sit here, Applejack, watch. Because you know it involves hay and you know you're going to want some. Deborah's cow eats 3 bales of hay every 4 days. So 3 is going to be the hay. Let's put an H next to all the 3s. H and H. And 4 is the days. So put a D next to all the 4s. Okay, which proportion can be, so we're looking for a yeah, can be used to determine H, the number of bales of hay Deborah's cow will eat in 28 days. So the 28 is the days. And days. All right, A, the hay and the days are lined up left and right. B, the hay and the days are crisscrossed, it's out. C, the hay and the days are crisscrossed, it's out. And D, the hay is on the top and the days are on the bottom. Okay, next, what I know between these two answers is the 3 bales has to be lined up with the 4 days. See how the 3 bales and 4 days is crisscrossed? Poo-poo. They're saying the cows eat three bales of hay in 28 days. That's not enough for those poor cows. Okay, so we're looking for the 3 with the 4. Yep, 3 with the 4 is lined up vertically this way. 3 bales in 14 days. How much hay in 28 days? D is the answer. Okay, if you have any time left, you're welcome to go into the Schoology, into the extra practice, and work on anything that you see that can be helpful in the extra practice. Bye.